Good morning to all. I am Dr.V.Sharmila, Professor, Department of Computer Science and Engineering, Kesar College of Engineering. Now, we are going to see about compiler. So, compiler is a system software. It is one of the translator which converts high-level language, that is generally converts high-level language into a low-level language. That is, it takes high-level language as a input and produces the low-level language or machine-level language as a input. But in compiler design, compiler acts as a translator which converts source program into equivalent target program. That is, and also compiler displays the errors, that is, detect the errors which are occurred in the source program and displays to the user in the form of error message. This is compiler. Generally, the compilation process has done in two different parts. That is, first one is analysis part, second one is a synthesis part. Analysis part and synthesis part. Compilation process can be done in two parts, analysis and synthesis part. Analysis part takes source program as a input and produces the equivalent target program as equivalent intermediate code as a output. And synthesis part takes intermediate code as a input and produces the equivalent target program as a output. That is, analysis part converts the source program into list of tokens, and then from the list of tokens, it generates a equivalent intermediate code. Synthesis part takes intermediate code as an input and produces the equivalent target program as a output. Next, the structure of a compiler. Generally, compiler consists of 6 different phases. That is, lexical analyzer. First one is lexical analyzer, syntax analyzer, semantic analyzer, intermediate code generator, code optimizer, and code generator. This is the block diagram of structure of a compiler. So first phase, lexical analyzer. It is the first phase of compiler. That is first part of compiler. It takes source program as a input and produces the list of tokens as a output. It is also in this phase also called as linear analyzer or scanner. It reads that is a linear analyzer, that is lexical analyzer, reads a character from left to right, one character at a time, and forms a meaningful sequences called as lexemes. It forms a meaningful sequence called as lexeme. From lexeme, the lexical analyzer forms a tokens. The tokens in the form of token name, comma, attribute, value. So token name and attribute value. Generally, the tokens are variables, constants, and operators. Both are considered as a identifier. Okay, for an example, position equal to, consider this instruction, that is position equal to initial plus rate into 10. Here, position is a, that is, it's a group of character. It forms a lexeme. From this lexeme token, this is one type of identifier, that is comes under identifier. That is, position is a token. From this token, from this position is a lexeme. From this lexeme, token is formed. That is ID. ID means identifier. The position of, that is the attribute value of position is 1. So the equivalent token is ID1. Next, equal to is one of the token. Next, initial, it is a lexeme. From this lexeme, ID1, that is token ID1 is formed. Next, plus, it is the operator. It is also one of the token. Then rate, it is the lexeme. From this lexeme, token ID3 is formed. Star is the operator. The equivalent token is star. 10 is a lexeme. It is a constant. The equivalent token is 10. So the list of tokens are, that is ID1 equal to ID2 plus ID3 star 10. This is the output of lexical analyzer. That is a list of tokens. Second phase, syntax analyzer. It is also called as parser. It takes list of tokens which is generated by the lexical analyzer as a input and produces the equivalent syntax tree as a output. It is also called as parser. The syntax tree is a tree-like structure which consists of nodes and edges. Here, nodes and edges. There are two types of nodes, that is leaf and non-leaf. In syntax tree, leaf nodes represent operands, that is argument of an operators. Non-leaf node represents operators. This is the example for syntax tree. For the above listed tokens, the syntax analyzer construct this equivalent syntax tree. This is the output of syntax analyzer, that is equivalent syntax tree. Input is list of tokens. That is here ID1, ID2, ID3, 10 are leaf nodes. These are the operands. Equal to, plus and star are non-leaf nodes. Non-leaf node represents operators. Third phase, semantic analyzer. This is the third phase of compiler. It takes syntax tree as an input and produces the syntax tree with the type information as a output. The main function of semantic analyzer is type checking. That is, compiler checks the operator has matching operands. Suppose the operator has mismatch operands, means automatically it will perform type conversion. That is, type conversion means automatically compiler converts one data type into another form. Here, consider this syntax tree here. Leaf nodes, that is ID3 and 10, both are different data type. That is, for an example, ID3 is a float, 10 is a integer data type. So ID3 star 10 star has two operands, that is ID3 and 10, both are different data types. So compiler automatically performs type conversion, either float ID3 converted into int or 10 converted in 10, that is integer, and converted into float. Here int, that is integer. Int is a integer, it can be converted into float. Now both are same data type. This is type conversion. The main function of semantic analyzer is type conversion. The fourth phase is intermediate code generator. The intermediate code generator takes syntax tree with the type information as an input and produces the sequence of instruction as a output. Intermediate code can be represented by using intermediate languages. There are three types of intermediate languages. That is, first one is three-address code, postfix notation, and syntax tree. The most commonly used intermediate language is three-address code. The three-address code in the form of x equal to y, op, z. Here, x, y, z are operands. Op is a operator. Three-address code contains at most three operands because three-address code. Why it is called as three-address code? Because it contains at most three operands. In this part, the compiler uses temporary variables for storing the result of each instruction. This is the example for intermediate code. That is, first, intermediate code. Here T1, T2 are temporary variables. T1 equal to ID3 star into 2 float of 10. The result of ID3 star into 2 float of 10 is stored in temporary variable T1. Second step, then T1 is, the content of T1 is added with ID2. Then the result is stored into another temporary variable T2. Finally, the result of T2 is assigned to ID1. Next, code optimizer. It is the fifth phase of compiler. The code optimizer is optional one. The main function of code optimizer is to maximize, that is, to improve or optimize or improve the intermediate code. So improve here, improve or optimize means that is code optimizer reduces the number of lines in the source program. So why optimizer is needed means optimize means reduces the number of lines in the source program. Then the main advantage of reducing the number of lines in the source program is memory space is saved, and also the execution speed is high. That is considered this example, T2 equal to into 2 float of 10, T1 equal to into 2 float of 10, T2 equal to T1 star ID3, T3 equal to T2 plus ID2, ID1 equal to T3. And this is input of code optimizer. The optimizer and this intermediate will consist of 4 lines. The code optimizer reduces this 4 lines into 3 lines. So for an example, T1 equal to ID3 into 2 float of 10. The answer will be stored in temporary variable T1. Next, the content of T1 will be added with ID2. The result is again stored in another temporary variable T2. Finally, the content of T2 will be assigned to ID1. Here, the intermediate code consists of 4 lines. Code optimizer reduces this intermediate code into 3 lines. Next, code generator. It is the last phase of compiler. Last phase of compiler. Code generator takes intermediate code as a input because code optimizer is optional one. So only code generator takes intermediate code as a input and produces the sequence of assembly instruction, machine instruction as a output. Here, compiler uses register instead of temporary variables for storing the result of each instruction. The equivalent machine code is, that is assembly code is, first one, move R1, comma, hash 10. Here, the constant value 10 is moved to register R1. Next, the content of R1 will be multiplied with ID3. Then result is again stored in register R1. Next, third line, add R1, comma, ID2. Content of R1 is added with ID2. The result is stored in register R1. Finally, the content of R1, the final result will be moved to ID1. This is the equivalent target program for our source program. Our source program is ID1 equal to ID2 plus ID3 star 10. The equivalent target program is move R1, comma, hash 10, multiply R1 with ID3, add R1, comma, ID2, finally result, that is content of R1. R1 move to ID, identifier ID1. This is the target program. So compiler takes source program as an input and produces the equivalent target program as a output. Compiler construction rules. Compiler construction rules. Compiler, there are number of compiler construction rules are available. Here some of the, now we are going to see some of the compiler construction tools. Using these tools, we can construct the compiler. That is, first one is scanner generator. Scanner generator construct a lexical analyzer of the lexical analysis part of the compiler. Scanner generator, the output of scanner generator is list of tokens, which takes source program as a input and produces the list of tokens as a output. Next tool is parser generator. Parser generator takes list of tokens as a input and generates the equivalent syntax tree as a output. Third one is syntax directed translation engine. This tool converts the, that is construct the intermediate code generator. Next, code generator. Next tool is code generator. Code generator generates target program, that is code generator phase of the compiler. Data flow analysis tool used to construct a code optimizer phase. Next, final is last tool is compiler construction toolkit. This tool used to construct all the phases of the compiler. Using this tool, we can construct whole part of the compiler. Thank you.